Okay, so I think today I see more people, I guess, right? Good. Uh, so lecture at 8 o'clock is very good thing, right? Morning you are done and then you enjoy the beauty of mathematics over a cup of tea for the whole day, right? Anyway, so I think in the last lecture, the first lecture we actually I gave you some general tips, right? About UG study and so on and so forth. Uh, Today, first, I'm going to tell you about the story of ICT because many of you may not be knowing what is ICT, right? And whether CS is better, EC is better, all kind of questions, right? Brief, very brief, so that you have some essence of it. And then we'll talk about some story of mathematics, actually, right? And then we come to story of calculus. Okay, so I think more or less this much is enough for today. And so the next class, we will start the real stuff, okay? By the way, thanks. I think most of you have joined. Some of you are still not there on the WhatsApp group, but so I think now you will join, right? I sent an email. You got an email, right? All of you? Good. So if you have any doubt about any of these things, you can just send me a message or whatever, right? If you need any help, just let me know. Okay, so let me start. So ICT actually consisting of information communication technology. So I think 30 years before that, you know that in 80s or 90s there was more talk about IT industry, right? So everybody knows about IT. But then what is this ICT? Okay, so you see, IT comes from purely computer science, right? Only you're studying computer science concepts, right? And then say basically a computer. So initially, computer was not able to communicate. One computer was not able to communicate with other computer until it was discovered how when the internet was discovered and so on in 90s, early 90s, and then took more shape, right? Nowadays, you cannot see any computer without communication or any phone without operating system, right? So it's very rare. So basically now both of these things have merged. So communication technology and information technology. So their combination is ICT, information and communication technology, right? So as a ICT engineer, you should know all the basics of computer science plus all the basics of communication technology. Okay. And if you really want to become tech leader, you should also know the hardware because, both of these machines require a hardware, right? Some semiconductor device, right? And that's why all the three will give you ICT. So it is really very, very excellent degree over normal computer science degree, because otherwise, if you only doing computer science, you talk in the air. Without hardware, what will you do, right? Or if it cannot communicate, what is the point? So it is a better degree. So let me give you a brief idea about ICT. So actually, another thing, ICT is all about information processing in a very, very general sense. Information processing means, if you look around the nature or anything around you, things are changing. And there are devices which are processing information. There are nature which is processing information. Even the biology is also doing the same thing. So philosophy of information processing is very common, and ICT is everywhere actually. ICT is also there in biology. Not only that, suppose on a Facebook, you make another Facebook friend. Do you know how you can determine that? It's all computational processes that are happening around the world. So it's all coming from those information processing sense, those computational processes. Even your thought process, there is a book, What is Thought? Your thought process is also computational process. It's coming from sense of ICT. Anyway, so there are two aspects: communication versus computing. Right? And actually, they are two sides of the same coin. Mathematically, both are same. So basically, in a sense, whether you are communicating, so basically whether you are sending information from one place to other place, means communicating, or information, you are basically storing, means sending from now to then with respect to time, that is storage, right? So there are three aspects: information storage, information communication, and doing some processing on the top of it, right? These three aspects are very, very essence of ICT, and actually they are, interesting thing actually. So this picture summarizes everything. IT is application layer, and mathematical root is computer science, especially Turing machine. So some of you will be doing a course on models of computation, or I can watch some of my lectures on discrete mathematics. Most of the basic things are given there of that root. Turing machine. Turing machine is a thought computer, okay, which was suggested by Alan Turing in 1936, and that was the birth of computer science, basically. Okay, so basically it's purely mathematical thing, and then on one side now you have the application layer, which is IT. Second part is communication technology at the application layer, and mathematical root is theory of communication, essentially information encoding theory. So there are two aspects. Information theory was given by Shannon. It is because of Shannon that you see all this digital world now. So Shannon gave idea about if I want to send information from one place to the other place, or if I want to compress information, how much we can do. So he gave bounds. Okay, how much information you can send through some communication channel, and how much information you can compress. Compression is the answer is in the form of entropy. Okay, the similar idea which was entropy is there in the thermodynamics. I mean, he has brought those ideas into the communication things. Okay, that's a really interesting thing. And coding theory is all about algorithms for protecting the data, for error correction. Because whenever information processing is happening, whether it is in the nature or whether it is in any communication device or any computer, errors will happen. And to protect the errors, okay, you require coding theory, those algorithms. So that is that branch. So all that mathematical stuff builds the CT. Also, it builds in IT also. So their combination is very, very important. Also, even in the the hardware side. So both of these things are realized via logic gates and circuits. So hardware, software, electronics, all that semiconductor technology, right? So all the three things are very, very important. So as I mentioned in my previous lecture, you should not be unidirectional, but you should have 360-degree view of everything, right? How a software, how a device driver works, how things interact with each other. Those understandings are very, very important if you really want to be an excellent leader. Okay, that's why that understanding is very important. You could be very, very high specialist in one area, but at least you need to understand how all they interact with each other. So what is computer? Is a device or machine which processes information, right? And so there are two kind of registers. This is for classical computer. This is for quantum computer. Computer based on quantum physics, which is much more powerful. Okay, I will show you towards the end that there are problems for which classical computer is idiot box. You cannot do anything. Quantum computer can help you. Each computer has a limit. Okay, I'll show you that also. Each computer has a barrier known as Turing barrier. Okay, so there are certain problems which it will not be able to solve, whether it is classical computer or quantum computer. And that means there are certain fundamental questions you will never get answer if you think yourself as a machine, right? Obviously you might be having many questions in life, right? What happens after death? All those fundamental questions, right? You will not be able to answer with this approach. Science has a limitation also. Anyway, what is the purpose of computing? Is insight, not numbers. And that insight is very, very important. This is a word by Richard W. Hemming, who invented coding theory, error correcting codes. Okay, and all this is written in this book, Introduction to Applied Numerical Analysis. Pretty nice book actually by Hemming. So he was at IIT Bell Labs. So he invented coding theory around 1945. Communication, sending information. So actually communication is also sort of information processing only, right? What is information? That is another interesting question, philosophically also. And so it could be digital, quantum, chemical, biological, structural, social, natural. So there is a new word known as natural information processing, which combines all of them. Okay. So information processing is happening everywhere. In fact, Seth Lloyd actually asked a very fundamental question. This is all in terms of ICT I am talking about. How systems of all kinds, computers, atoms, brains, cells, societies, and the universe as a whole process information. Okay. So ultimate thing is information processing that is happening everywhere. So from that angle, if you look at ICT, right, you find that it is everywhere, right? So in society also things are changing, right? Information is changing. And you see, believe, in calculus, I'll tell you what, so calculus means you are calculating the change, right? And that's what, how do you do that? Anyway, so, and also there is another word, which is quantum ICT. So this is all, could be classical information processing or quantum information processing, right? Quantum ICT. So it's a highly interdisciplinary area, gold mine for science, technology, and business, all the three. It involves mathematics, chemistry, nanotechnology, medicine, everything, physics, biology, computer science, electrical engineering, communication, everything is there, right? Anything is left? Business is also there. So you are lucky that you are in ICT course. Okay. So anyway, now I'll give you some emerging areas. There is another quote by Edelman. I don't know whether you are you aware of Edelman? No, no reading. Okay. So have you ever logged in your bank account? So you see that you see HTTPS, right? So when you log in, so there is an algorithm that goes at the back end. So discovered by these three people, Rivest, Shamir, and Edelman. Edelman is one of the cryptographer here who invented that technique. Okay. So RSA algorithm is based on factoring integers. Okay, I'll tell you why that is important. So he actually invented, I mean, even another area which is known as DNA computing. So you can compute with DNA molecules also. You can make computer out of DNA molecule also. And so he has made this quotation: biology and computer science, life and computation are related, and I'm confident at their interface, great discoveries await those who seek them. So this is a message for you, all you young people, that if you look at biology and computer science, you get wonderful things to work from the perspective of ICT. Okay. Now, some emerging areas at the intersection of mathematics, computer science, and biology. Of course, biology and computer science, tons of things are there. For example, in biology, there is a computational biology, systems biology, and the recent one is synthetic biology. I don't know whether you know. Have you heard of CRISPR? CRISPR, anyone? Okay, good. So CRISPR is the most disruptive technology ever discovered by mankind, right? Using CRISPR, you can modify your genes, okay, by programming, and you can actually switch off something, switch on something, right? All kind of things. So you can actually play with the human body and all other animals, right? It's very, very. So I think people are trying. There is a fish in the ocean, zebra fish. I think if you cut the fawn, it will regrow. Now scientists have taken that gene and then implant that gene into humans. So maybe you can regrow some organ also. And actually, they have tried it in a hen. So they cut the leg and it was regrown, right? So those kind of things are possible by programming, computer science, biology, mathematics, everything is there, right? So real ICT, right? Those kind of things are possible. And so synthetic biology is the most important area. Security in cryptography, I think this is something, very good impact, because whenever there is a computer, people will be there who will do all kind of bad things. So you do require protection, right? Quantum computing is another area, because there are certain problems which you cannot solve with classical computer. And of course, cryptography is there. Quantum machine learning, how many of you heard of machine learning? Machine learning, and most of, what about quantum machine learning? Quantum machine learning is another new buzzword actually in the market. And prompt engineering is pretty recent, right? From last October started, right? Prompt engineering, have you heard of? Some of you, very good. So prompt engineering is, how do you ask ChatGPT a specific question to ask, right? For example, there is a recent paper by Google, like chain of thoughts, that your query should be decomposed into a bunch of chain of thoughts, and then you process it, then it will give you the correct answer. Multiple opportunities are there if you actually acquire that skill right now. And as I mentioned, one course in my last lecture, that there are now courses available, very recent one. Of course, so you can do some of those things. These skills are important for you, right? And if you don't believe me, you can believe Steve Jobs, right? His quotation: the biggest innovation of the 21st century will be at the intersection of biology and technology. So a new era is beginning. Now you see, till now you have been seeing biology, to dur thi. I don't want to study, right? I am an engineer. But now, entire ICT is subset of biology actually. You will not find anything, whether it is operating system, any concept which is already not there in biology. So you have a big playground to play with, right? So as I mentioned, because see, if you want now designer babies with high IQ, you can do that now. And if you want to have 4 eyes, you can do that also. Of course, as long as the government will allow you to do that. But those kind of regulatory things are there, but all those things are possible in principle, right? With that kind of power you have with biology actually. Okay? And it all involves computer science, mathematics, and of course biology, chemistry, physics, everything is there. Okay, so essentially now which degree is better? I hope you know this answer. Probably I can quickly skip these slides, but ICT versus computer science versus EC, right? Versus ICT CS is also there, right? So ICT degree is 21st century degree, right? I'll give you briefly what do you mean by ICT CS as well. Okay, why? Because ICT degrees prepares you for actually interdisciplinary skills, right? You have all the other things, right? So you are in much more demand. Okay, if you join, so as an ICT engineer, you can join Qualcomm. As an ICT engineer, you can join Google. As an ICT engineer, you can also join Microsoft. Whatever way you want, right? Whatever path you take, all the paths are open. That is much better if all windows are open as compared to one narrow window, right? Okay, so this is much better thing. Now, by the way, do you know that after BTech in ICT, you can join MD PhD program without doing MBBS at many good universities. So that path is also open. MD PhD, right? What people do after MBBS. There is a Harvard MIT program with very good scholarship. I think at some time of back, it was $125,000 per year. Now I think it must be more. That is also you can do if you want. See your scope, how much is open now, okay, with this degree. Now, what is this computational science? What is CS? As I said, communications and ICT, those are the two branches of computer ICT, two sides of the same coin. So science, you want to study the nature, right? So there is a theoretical science, experimental science, and computational science. Means you want to simulate the nature basically. Okay, you want to write programs and take the situation, for example, drug discovery. So there are many drug molecules, right? And if you try to do experiments every time, okay, you discover new molecule which can block certain things, right? And you want to try it in the lab, it will cost you. Okay, if it's not successful, then you lose the money, right? So people, what they do a simulation. Okay, do the simulation, check 10 molecules, whichever seems to be better fit, then you do the experiment for that. Okay. So that is more or less about in computational science. Many people don't know what is computational science. I am telling you, it's all about simulating the nature, right? Simulate it and see what happens. Simulations are very, very important. By the way, as an engineer, it's a very, very common trick. Okay. Suppose errors are happening. So what? One way is you do all mathematics, analyze how much is possible, how many errors will happen, all that analysis. Other part is simulate kar lete hain, right? And 2 millions में एक जगह पे error होगी, right? So that is okay, right? We can build the system, and it's a very, very rare chance. Right? So those kind of things people do. The simulation is very, very important aspect, right? So you simulate the things, right? So, so this is basically basic thing. So essentially, what is ICT is if ice cream, this is your CS at the top of it, right? So I hope you got the idea about CS. What is ICT? What is ICT CS? Okay. So I hope now you don't have any doubt, right? So this is all about ICT business. Okay. So now, any question about now your ICT CS? You can tell others and your parents also, right? Because they will be asking question. What is ICT? Why you are doing ICT? Why not what is ICT? Many people think ICT CS means only computer science, right? So that is the wrong notion anyway. Now I am going to look at now the real course I am going to start. Basically, first I will talk about the historical development in mathematics and then historical development in calculus. And towards the end, I will show you some beautiful examples which you should enjoy on your cup of tea. Okay. Since you know, by the way, how many of you are able to solve that sine x cube I gave last time, sine of x cube? Okay, so we will. So why don't you share it in the WhatsApp group? Hey, I have not seen yet. Okay, so that's something interesting anyway. So what is calculus? So as ICT, information processing is going on everywhere in the nature, things are changing and you want to calculate change, rate of change of everything. And that is all we study in calculus. Very simple thing, right? Calculus is all about measuring the change everywhere. So let me give you some brief history of mathematics and then we'll go to the calculus. So some beauty of Indian mathematics, right? Obviously. By the way, you know that why I have put this picture here? Any idea? So, people say that, normally in India, I think I don't know where, the Pani thing, Sanskrit, Pani written that Ashtadhyay. I don't know whether have you read that Ashtadhyay? So there actually all those sutras are they've given there, the grammar for Sanskrit and so on and so forth. And actually, the alphabet comes from dance of Shiva. That's what it is written there. You can read it. Okay. So the dance of Shiva gives you certain, I would say, frequency or sounds, and that creates alphabets, and those are precisely beautiful fit in your mouth. Whatever sounds are possible in whatever combination. Purely computer science I am talking about. So essentially, dance of Shiva gives you combination of computer science. So whatever sound vibrations you can create from your mouth is captured in those alphabet beautifully. So I think you might have seen, right? I mean, I can give you some example. For example, in Hindi, you see that there is a ka, kha, ga, gha, right? So there is one thing is attaching other thing. Ta, tha. So now tongue is putting, you are putting on these teeth. Ta, tha, da, dha, na. There are 5 points from where all the kind of sounds are created, right? So essentially, it's a very, very beautiful thing. Actually, you see the combination. It's all, very, very mathematical, precisely beautiful. It's all computer science, right? This is not there in other languages, by the way. Okay. I'm saying the Indian languages, this is very common because all came from Sanskrit. By the way, there are so many beautiful work done by so many mathematicians, I think. As I mentioned, Panini is around 520 BC. And, so there are all kind of mathematics, Vedic mathematics, Indus Valley mathematics. Ruler, the first ruler was found here in Gujarat, right? I think I don't know whether you know. Measure, the scale was there in here. Jain mathematicians, they have done a lot of Jain temples were there in Gujarat, especially Patan. There was some great mathematician with this geometric. So these are the 4 kind of mathematics, and especially geometric and mathematical and algebraic origin was there. Some main contributions, numerals that we use today, ideas of zero and infinity, abstract meaning of numbers, geometry, trigonometry, sine of any angle, infinite sum, value of pi. Pi is a beautiful thing, right? What is pi? पूरे ब्रह्मांड में, in any universe, I mean in universe, anywhere you go, draw a circle, right? Measure the diameter, measure the circumference, take the ratio, that is pi, right? Universal constant. I have a very nice question for you. T-type problem. You have to think. So now we are saying by definition, pi is ratio of two numbers. But you remember, if it is ratio, it's a rational number. So pi is it a rational or irrational number? Irrational. But why it is, no, here it is ratio? Think over it, right? No, but that by definition I am saying pi is ratio of two numbers, right? Circumference, length, and diameter. So why we are calling it irrational then? So beautiful. By the way, I should tell you another interesting thing. On this planet, if you measure source and destination of all the rivers, so the zigzag path they take and the actual distance, and take the ratio, average ratio turns out to be pi for all the rivers. Beautiful thing, right? So mathematics is everywhere, right? So you see, okay. So this question is for a T-type problem. I think you will think about it, right? And maybe tell me. And calculus is also, of course, the birth of calculus happened in India, computer science, astronomy, all kind of things. So let me show you. Origin of zero, as I mentioned. So I think I don't know whether you are able to find. So this is the as per written document. I don't know whether you know about this Bhakshali manuscript where the zero is written. But apart from that, in Vedas already zero is mentioned, right? So I think it is very old. And I think it is very difficult to actually pinpoint who discovered zero, right? But I think people think Aryabhat is, I mean, I don't know who taught you all those things, but that's not correct. Anyway, so this is the manuscript. And there is a temple in Gwalior where on the wall zero is there. The oldest existing zero in Gwalior region. Okay. So Bhaskara Charya II, he was the head of astronomical observatory at Ujjain. Ujjain, I think somehow, it's very beautiful city. And you will see a lot of interesting things there, astronomically as well. So I think you can find it out. So ideas of infinity, right? I mean, this idea as x gets bigger and bigger, 1 by x approaches towards zero. Conversely, as x gets smaller and smaller, 1 by x approaches towards infinity. Those kind of ideas were, given by Bhaskaracharya very clearly. And his major work was solving equations, Diophantine equations, arithmetic terms, progression, geometry, differential calculus as well, right? So all these books are available, you can read. Okay. Origin of trigonometry is in India, right? So about the curved lines and so on and so forth. This is, I think there is this temple there in Ujjain, and I think one is in Delhi also, right? Where you can find out certain things. So how you find the distance, those calculations can be done. This idea of convergence that we are going to study in calculus was already there in this, as I mentioned, Madhavacharya. He gave this formula, Madhavacharya series. Pi by 4 is nothing but this. The value of pi you can summarize from here, right? So all those things are interesting, right? Then there is a timeline of European mathematicians who have contributed a lot in mathematics. Okay. And I think you can see the last one is Ramanujan. So do you know Ramanujan? Have you visited his house? I can share some pictures. I visited his house and I have also seen that temple. Okay, Namakali Devi temple, where actually in that village, most of people are mathematicians. Okay. So it's really factory of mathematicians. Okay. There, people say that it is all gift by that Devi. Okay. Now I'm going to give you, these are very beautiful books. You should have this on your table. 17 equations that change the world. Okay. And a lot of them are involving calculus as well, right? So this is Ian Stewart. I have been reading his articles since 80s. Okay, so it's beautiful mathematician in England, and he has written many interesting books actually. So this book, from where I have taken these 17 equations. You will see, both of these books are good actually, by the way. Okay, whatever is known as Pythagoras theorem, you know that it is known as the Bose theorem, right? Which was discovered, I mean, in India, it was known already 1,000 years ago. Okay, so what does that mean? The square, I think you know what it means. You can see that the modern use is triangulation is used to this day to pinpoint relative location of for GPS. This is very common application of Pythagoras theorem. Okay, log. This is very interesting thing. Okay, so you can multiply numbers by adding related numbers. This is something a very important thing, right? So this is still so logarithm is still inform our understanding of radioactive decay. This is the modern use. Of course, there are a lot more other important things in calculations, especially in probabilities. It is very useful. This is something from your course itself, right? Everybody knows this beautiful thing, beautiful formula. So calculation of the rate of change, right? So this actually created the modern world. Calculus is essential in our understanding of how to measure solids, curves, and areas. It is the foundation of many natural laws and the source of differential equations, right? You will see that why it is so important. Medicine, economics, computer science, biology, everywhere it has wide applications. We'll talk about it. Gravity, right? This formula, this you might have read, right? Force of gravity between two objects. So satellite TV is possible because of this. A lot of applications you can again see, right? For this gravity business. This is another beautiful thing, complex numbers. I love complex numbers actually, And if you love complex numbers, you can make $1 million. You want to do that? I can tell you sometime, right? There is a prize. Okay. So I'll talk about it sometime later. So they are, I think, quite useful. And why do we need it? I'll tell in third lecture maybe. Euler's formula for polyhedra. Okay, it's very useful for biology and DNA and other things. Normal distribution. Have you heard of normal distribution? Some of you might be. I don't know. Otherwise, okay, fine. So in the drug side effects, people study it in clinical trials and so on. Wave equation is another very beautiful thing. Okay. So oil companies use this equation quite a lot. Fourier transform. I think this is something very fundamental. Okay. And Fourier transform was discovered because of differential equations, which I'm going to talk about it. Basically the idea that a function can be approximated by by a combination of sine and cosine. It's a very beautiful thing. Okay. And profound applications everywhere, especially in quantum computer. If you want to develop an algorithm, you need to first look at quantum Fourier transform. So the quantum version of Fourier transform is also there, right? It's very beautiful. You will see that your signal and system and communication, the backbone is Fourier transform. It's very important. Okay, and it's wider applications in everywhere. In fact, a specific case of it is used in JPEG, JPG pictures you take, right? So there is a video I will share with you. You will see that discrete cosine transform is used for image compression in JPEG. In fact, we are contributing also in JPEG standards. We are part of it actually now. So now we are developing standards for how when you store images on DNA. So you can store images on DNA. Okay. So there actually now scientists are developing standards how you will store that. Okay. These are another beautiful equations, Navier-Stokes equations. Okay. So modern passenger jets are one of the applications. It's very useful actually. in describing and solving is actually some of the solution for partial differential equations. We don't know how do we solve it actually. It's a very, very challenging thing. Maxwell equation. In the universe, anywhere, whenever we are talking about electricity and magnetism, these equations have a bigger role to play, right? It's very, very important. Okay. So these are, so radar, television, modern communication, and nothing is possible without Maxwell's equation. Second law of thermodynamics, very useful. Einstein's theory of relativity, I think, by the way, on YouTube, you can find how GPS was discovered. It's a very interesting story. You know GPS everywhere. Now each mobile has it, right? But how it works, how it was an accidental discovery. You see, most of the beautiful discoveries are accidental. And it happens to only those who are prepared well, right? Otherwise, it will not happen. So your mind should be prepared. And these 4 years, you can do the same thing. Just prepare yourself so that you can also discover great ththings, right? Schrodinger equation is very important, essential for the use of semiconductor, transistor, and modern computer technologies. Very beautiful thing. And for quantum, obviously, it's very, very important. Shannon, as I told you about Shannon theory, right? So very, very, it's a bound actually, right? So this estimates the amount of data in a piece of code by the probability of its component symbols. Beautiful result. And there are some lectures available about on my channel. If you want, you can learn more about error correction and error and the detection and so on. Logistic model for population growth. This is very important. Used to model earthquakes and forecast the weather. So weather forecasting. So this helped in the development of chaos theory. I don't know whether you know chaos is a beautiful thing. This is for those who are interested in financial market, right? These are the very, very famous equations. All are output of calculus only, right? You can see that, right? Differential equations, right? So the variance I still use to price book the financial crisis. This is something really interesting. I'm not going into too many details, but I'm giving you glimpses, right? So that you can obviously go back and look at. Now, mathematical innovation is also there in fashion. Okay, I will show you briefly. शास्त्र अनंत है विद्या का पारावार नहीं है ऐसे में मनुष्य सदैव मूल तत्वों पर विचार करना चाहिए. So I am showing you some small things because there are so many unlimited things. I can talk about maybe 40 lectures only on applications, but that is not possible, right? So anyway, now I think here, let me first show you one article, how to build a search engine for mathematics. This is published in Nautilus magazine. In fact, I have also given an interview here. You can look at it. This is all about sequences. In this nature, as I mentioned, everywhere information processing is going on, right? I hope you believe this now. Now, when information processing is going on, means some computational process is going on. And numbers are output of those computational processes. Okay? So, everywhere computational processes are going on, numbers are output. And so, if in one computational process, which is say related to biology, another computational process, which is related to say maybe physics or whatever, some maybe mechanical engineering, right? Now, suppose this number pattern and this number pattern is same, that means these two problems are related to each other, right? Because ultimately it's a computational process. So these number sequences connect one thing to the other thing. So it's very, very powerful thing, actually, if you can see which pattern. So I'm sure you might have heard about Fibonacci numbers, right? As I mentioned, before Fibonacci, it was discovered by many Indian mathematicians. Hemchandra is one of them, and Gopala. Gopala was in Gujarat only, right? So now they are calling Hemchandra numbers, but also people are calling it Fibonacci numbers anyway. So okay, so these are the output of nature. So I encourage you to read this article. This is a very beautiful article. How to build a search engine for mathematics. Okay, and here. You can go to this online encyclopedia of integer sequence. Neil Stone was at AT&T Labs. So he has built this large database of integer sequences. And as you can see that there was a party in 2006 when I mentioned this. Integer sequence connect the whole of science. And I always mention that in my class that I teach and students get excited. In fact, in every class, whenever I talk about integer sequences, students are able to discover some new sequences on their name. On this database, you search DICT, you will find many students who have discovered new sequences, just like Fibonacci. What is your name? Palak. Huh? Mahak. So I want to see a sequence with the name of Mahak, right? Mahak sequence, right? You discover a new sequence. Okay, each of you, it is possible. By the way, my daughter has discovered recently. She's in class 7th actually. So anybody can do this, right? Just try to discover new sequences and put your name. Tomorrow somebody will refer your name, right? Just like Fibonacci or whatever, right? So this is there at online encyclopedia of integer sequences, okay? By the way, this is your famous sequence 1, 1, 2, 3, 5, 8, right? As you can see that. So are you aware of this golden ratio also? Might have heard. Might have seen some of you who are little bit excited about mathematics. You might have seen in cauliflower or maybe pineapple and sunflower. These kind of numbers appear everywhere, right? There are plenty of beautiful things. For example, you see, suppose from here you go to US, and you know that in US there is no kilometer. They talk in miles. So these numbers could be useful for you. For example, 2 miles is approximately to 3 kilometers. 3 miles is approximately to 5 kilometers. 5 miles is approximately to 8 kilometers. 8 miles is approximately to 13 kilometers. Keep on going along the line and you get better and better approximation. These are the beauty, right? So you can convert between kilometer and miles using these numbers, okay? Okay, so this is something really nice. And there, tons of things are there. They appear everywhere, even in your stock market. People have built algorithms. There is a company known as Fractal Dynamics, which is actually working on these things only. They're applying these concepts in a stock market to predict it and doing all business. This is the beauty of mathematics and power of mathematics. If you understand, if you love mathematics, you can make a lot of money, right? Now you see, it is inside your body also. The ratio between length of your hand and the length of your forearm approximate 5. You can measure it. Try and measure it, you will find this thing. Okay? So how to use it in the fashion industry? There are many ways you can do this. I am showing you one way. Suppose the ratio of jeans and top. This ratio is 1:1. And this is 1:1.161, the golden ratio. This looks more beautiful than this other one. So this is the application in fashion industry, right? Okay. So all kind of things are possible using mathematics. By the way, this is a picture very important for you to remember. This is the output of a first computer program ever written in the history of mankind by binary coded punch card. So program was written in the binary coded punch card to produce this picture in this loom business in Europe. And in that range, 1805 actually, when this was done. The first computer program ever written. If you want to know more about beauty of mathematics, you can read this book by Stephen, The Joy of X. He's also written a book, Joy of Y. But so I think you can look at it. Anyway, there is limit to mathematics. There is also a nice book. As I mentioned, there is a limit to science. At certain point, there was Professor Srivastav. Now he's no more in US, I remember. So he used to, after reading some work of Alan Turing and those ideas as I mentioned, because there is a Turing barrier. So as I mentioned, computer science has a limitation. So beyond certain point, you cannot do anything with computer science, right? No matter which machine you take, whether it is a classical computer science or a quantum computer science or whatever, there is a limit. If you think yourself as a computer, actually there is a model. that our brain is a quantum Turing machine. Okay, so there is a limitation how much you can answer. That means you will never have answer to these fundamental questions. So since then, when he realized, he was a very great professor, there is a famous theorem on his name. So he then after that he left everything, and he was keeping a picture of Lord Krishna wherever he goes, and he's changed himself. That science has a limitation kind of thing. You can do well up to certain level. So those kind of things are there anyway. So this guy is known as Omega Man. So just again a tea time problem. What is Omega? This guy is known as Omega Man. I met him in 2000. Yeah, in the year 2000. Gregory Chatin, when I was in New Zealand actually. So there are many beautiful books he has written. You can look at Limit of Mathematics. And they are very interesting. He was at IBM TJ Watson Research Lab. And I think IBM was just keeping him because he was very famous. At very young age, he did PhD. 16 or 17 years of age, right? So just like you people can do PhD at this age, right? So it's an interesting thing. Gregory Chatin. Okay, now I will show you how you can make money out of mathematics. So there are some beautiful examples in front of you. This is the honors class. By the way, David Hilbert in 1900 in International Congress of Mathematicians in Paris gave list of 23 problems. Some of them are still unsolved, and later on Clay Institute actually out of those 7 problems, Clay Institute announced $7 million. If you can solve each of them, you will get $1 million for each. That is there. The birth of computer science happened because of those 23 problems only. Okay, so David Hilbert was a mathematician, he's a very great mathematician. He used to ask these questions: is there a mechanical procedure through which you can prove anything? Because in mathematics, you try to prove something. And it turns out that you cannot do that. And Alan Turing misunderstood the word mechanical. He thought he's asking for a machine. And he started making a machine now that is known as Turing machine. Okay. So sometime actually, if you have time and you visit US, in California, you can actually see a very nice museum of computer science. You can see beautiful discoveries. Okay. Even the first Google server, which was there, and all kind of things are there. Okay. Anyway, so you see, it is all because of this David Hilbert, these 23 problems. You are going for BTech in ICT or whatever, right? So if he has not asked those questions, he said that he will be remembered forever for these 23 problems. Only listed problems, that's all. No solutions. So I will also give you a lot of problems. Tomorrow, maybe some of you can do it, okay? So anyway, so this is a honors class. So these are 7 problems. As I mentioned, Poincare conjecture was solved by a mathematician who was surviving on a mother's pension, and he declined $1 million also. He's still there. They're all kind of mathematicians. There are many claims for solving Riemann hypothesis. This is close to my heart, involving complex numbers. So if you want to work with me on Riemann hypothesis, you are welcome. Okay. So this is something really interesting. There are many other problems. This is very interesting from computer science perspective. Okay. So P versus NP problem, I think it is in terms of Turing machine. If you can solve in polynomial time a problem on Turing machine, this is known as P class problem. If you can solve a machine on a non-deterministic Turing machine in polynomial time, it is known as NP class problem. Whether P is equal to NP or not, this is an open problem. If they are same, then Tufan aa jayega, right? That will be a very great thing. But anyway, that is still not there. The greatest prize in mathematics is Abel Prize, around 6 crore rupees, right? 7.5 million. So this you can get if you do good thing. There is another medal which is very popular, is Field Medal in mathematics. So making lots of money from maths and physics. This is a pretty recent one actually. 15 July. Yeah. See, stock market. A lot of things. So in the financial world, you can actually do wonders if you love mathematics and especially calculus. What happened this? Okay. This is a mathematics of Blackjack. I don't know whether you know MIT Blackjack team. Some of you might have seen this movie on Netflix, 21. So watch 2008 film 21. You will see how a professor at MIT and bunch of his students using mathematics, they won a lot of money in Las Vegas, right? After that, they were banned actually, so this is something, a beauty of mathematics. They were using the trick of card counting actually and calculating certain probabilities, and then they always win, no matter where you go. So it's a very interesting thing. You can actually watch this movie, 2008 movie, 21. And there are many more examples. I'll show you now this RSA, as I mentioned. When you log into any banking system, when there is a HTTPS, actually you use this algorithm RSA, which is backbone of current security on the internet. These three people were involved: Rivest, Shamir, and Edelman. By the way, Edelman, of course, invented DNA computing. Shamir is working in biology, and Rivest is a professor at MIT. So most of the people are shifting towards biology because there are more challenges there, okay, and to solve. And so how difficult is factoring a number? I don't know. You have written a computer programs, right? Now you see, if I ask you to factor a 2000 digit number, so Umesh Pujarani is a professor at UC Berkeley. So you see the statement I'm reading. It's not just a case that all the computers in the world would today be unable to factor that number. It is really much more dramatic. Even if you imagine that every particle in the universe was a classical computer and was computing at full speed for the entire life of the universe, that would be insufficient to factor that number. That much difficult a problem. Factoring a number into prime products. You know that fundamental theorem of arithmetic says that any number greater than 1 is product of prime factor. 15 is 3 into 5, right? 16 is 2 raised to the power 4. 2 into 2 into 2, 4 times. Any integer can be factored into prime factors. We don't have efficient algorithm for factoring integers. And that was the trick exploited by these RSA company to build the secure crypto system. You will look at about this in your discrete math class, or if you want, you can look at that lecture actually. So I'll just finish it in 1-2 minutes. That's all. See, these are the numbers, RSA numbers. So prices were given. I mean, $1,000, $4,000, all these things prices. So 100 decibels. So RSA 100, RSA 110. So binary digits are how many? 100 decimal digits are how many? And you can see that this was factored till 2020 is the latest 250 digit number. By the way, this is discontinued now. These prices are now $75,000 and more. These prices are discounted because now we are actually, having quantum computer. Quantum computer can factor integers very efficiently. Okay, so that's the reason. So this price has been discontinued, but still, if you can factor any of these things, I mean, you will be famous anyway, right? And you can do, I mean, you can get whatever job you want, whatever admission you want, all those things, if you can factor some of these numbers, right? So something for you to think about. So you see, I mean, some samples. This is RSA 250. These are the product of, these are the two prime numbers. Their product is this number. RSA 260, we don't know. It's still open. Anyone for tea time problem? Take a cup of tea and see if you can factor this, right? Obviously, it will be a small, short, beautiful paper, small paper, and you will be world famous, right? Yeah, you have factored it. Okay. This RSA 270, 270 digit number is still open. RSA 896 is still open. So there are many. Okay. For some of them, actually, the price is around $250,000. Okay, so you can make a lot of money. By the way, Paul Ados was there. I think I can stop here. Maybe you want more, or this is the so Paul Ados, I should mention, was a great mathematician. There is a Ados number on his name. He used to have a small briefcase and traveling all over the world. Okay, and he gives a lecture, interact in the department, talk to the students, and whatever money as an honorarium he gets, he give it to all the students. And he has written more than 1,400 papers. That's why scientists created what is known as Ados number. Any person in any field, if he does publish something, he has got a Ados number. Every mathematician has a Ados number. All great people have less Ados numbers. For example, Bill Gates has 4. Most of the Nobel laureates have very small ADOS number. Okay, everybody has ADOS number. Accidentally, I also have ADOS number close. Which is 2. But of course, I cannot have 1 because I have not got chance to work with ADOS. But yeah, so this is something there. This is Tetrometry is a very famous mathematician in the world. He writes one paper, the whole industry is created. That kind of person is there, right? At UCLA. So if you want, maybe you want to work with him sometime, He's actually, Tetrometry is with Paul ADOS at a very young age. You can see that, okay? I think that's all. You can join this SIAM, Society for Industrial and Applied Mathematics. This you can take a membership, undergraduate students. Sometimes they give me free membership. I can give it to 2-3 students if you want, actually, right? But you have to buy. It's not much, but you can have it. I think that's all. So next time I will going to start story of calculus. Any question at this point? Fine. I hope you saw the beauty of mathematics. Okay. So some of the T-type problems I have given to you. So you remember. If you are able to solve it, please share it on the WhatsApp group. Thank you.